Here's an introduction to ring opening reactions of epoxides under acidic and basic conditions. An epoxide is a cyclic ether, a three-membered ring which includes an oxygen atom. Two key factors contribute to the reactivity of epoxides. First off, being a three-membered ring, the epoxide has much ring strength, making it subject to ring opening reactions. Secondly, due to differences in electronegativity, the carbon-oxygen bonds are polar, resulting in a partial negative charge on the oxygen and a partial positive charge on the two carbon atoms. Together, these two factors make the electron-deficient carbons prone to nucleophilic attack, thus opening the epoxide ring. Although epoxides are a relatively reactive species, the ring opening reactions are greatly accelerated under acidic or basic conditions. Under acidic conditions, a general monosubstituted epoxide, when treated with an acid in red and a nucleophile in blue, yields a general ring open species with the nucleophile attached to a more highly substituted carbon atom. In a specific example, this unsymmetrical epoxide, when treated with sulfuric acid and methanol, gives the ring open species, which features both an alcohol and an ether functional group, where the oxygen of the ether, originating from the nucleophilic methanol, is attached to the more highly substituted carbon atom. The mechanism of acid-catalyzed epoxide ring opening is as follows. First, the epoxide will deprotonate the acid catalyst, HB, to form the protonated epoxide intermediate. In its protonated form, the epoxide, bearing a positive charge, is an activated electrophile. The positive charge is delocalized between the oxygen atom and the more highly substituted carbon atom due to the electron-donating nature of the substituent. A weak nucleophile will thus attack the carbon that bears the partial positive charge, thereby breaking this carbon-oxygen bond, resulting in the protonated ring-open species. This intermediate will be deprotonated by the conjugate base of the original acid to yield the ultimate ring-open product and regenerate the acid catalyst. Under basic conditions, a general monosubstituted epoxide, when treated with a strong nucleophile, yields a general ring-open species, with the nucleophile attached to a less substituted carbon atom. In a specific example, this unsymmetrical epoxide, when treated with sodium ethoxide and ethanol, yields the ring-open species featuring an alcohol and an ether, where the oxygen of the ether originates from the sodium ethoxide salt and is attached to the less substituted carbon atom. The mechanism of base-catalyzed epoxide ring opening is as follows. An epoxide is a weak electrophile due to its electron-deficient carbon atoms, making it prone to attack by an activated strong nucleophile, abbreviated here as Nu-. The negatively charged nucleophile will more readily attack the less substituted carbon atom of that epoxide because there is less steric hindrance at that site, thus breaking this carbon-oxygen bond and forming the ring-open alkoxide intermediate. This intermediate, being a strong base, can be readily protonated by a proton source, such as the conjugate acid of the anionic nucleophile, abbreviated here as NuH, thus forming the final ring-open product and reforming the nucleophilic species.
Gotta get a move on before the sun. I hear my baby calling my name, and I know that she's the only one. And if I die in Raleigh, lives down, we'll die free.